the course on basic electronics. The course code is 23CT23B. Myself Umayas, Assistant Professor, Department of ECE, SJBIT. In this session, we will discuss about Module 4 and its title is Fundamentals of Digital Electronics. And this chapter consists of these are the contents: digital computers and digital systems, binary numbers, number base conversion, octal and hexadecimal conversions, axiomatic definition of Boolean algebra, basic theorems and properties of Boolean algebra, Boolean functions, canonical and standard forms, other logic operations, combinational logic, introduction, design procedure, and adders. So these are the content of this module. So the first thing is about digital computers and digital systems. So this digital computers and digital systems. A digital computer is a digital system that performs calculations. So by processing certain information in discrete form. So the in a information in a digital computer is represented by variables that takes a limited number of discrete values, like often using only the two digits 0 and 1, known as binary code. So the digital computers can be programmed to perform a wide variety of calculations and functions, and they can store large amounts of data and retrieve it. Digital systems in general, it represents information with discrete symbols rather than with a continuously varying quantity as in an analog system. Digital systems have many advantages over analog systems, including some of the parameters like accuracy. Digital systems can produce accurate results. Reliability is one more point. Digital systems are more reliable than analog systems because they are less susceptible to noise. Speed. Digital logic elements can produce an output in less than 10 nanoseconds. Economy. Digital signals can be processed by cheap digital circuit components that can be easily produced in many components on a single chip. So here this digital computer can be divided into four types based on their size and type, like microcomputer, mini computer, mini frame computer, and supercomputer. So basically any of a class of devices that is capable of solving problems by processing information in discrete form. So this operates on data including magnitudes, letters, and symbols, so that are expressed in binary code, that is using only the two digits 0 and 1. So that's why this when we talk about digital computers, so it all deals with a sequence of zeros and ones, as the computers doesn't understand the language that we feed, like it may be English, Hindi, or whatever may be the language. So the computer doesn't understand the language. So the language is just an input. So that input is given to the computer and that is converted in terms of sequence of zeros and ones. And coming to its hardware part, like the hardware consists of all the electronic components and electromechanical devices, so that comprise the physical entity of the device. The software of the computer consists of the instructions and data that the computer manipulates to perform various data processing tasks. It'll be like if you consider a digital computer, it'll be consisting of memory, the random access memory, which we call it as RAM, central processing unit CPU, input output processor, that is IOP, input devices, and output devices. The central processing unit contains an arithmetic and logic unit for manipulating data, a number of registers for storing data, and a control circuit for fetching and executing instructions. The memory unit of a digital computer contains storage for instructions and data, the random access memory for real time processing of the data, the input output devices for generating inputs from the user and displaying the final results to the user. The input output devices connected to the computer include the keyboard, mouse, terminals, magnetic disk drives, and other communication devices. The logic gates are the main structural part of a digital system. The logic gates are a block of hardware that produces signals of binary 1 or 0. When input logic requirements are satisfied, each gate has a distinct graphic symbol and its operation can be described by means of algebraic expressions. Right. So coming to before we start with the logic gates, so we'll discuss few things about code conversions. That is code conversions in digital electronics. So this code conversion basically it's a process of changing a code with a specific bit structure to another code with the same or different number of bits per character interval. In digital electronics, a code converter is a logic circuit that takes bit patterns representing numbers or characters in one code and outputs the corresponding representation in a different code. So these code converters are used in many applications, which includes control systems like integrating systems that use binary and gray code, signal processing, translating between binary and gray coded signals, analog to digital conversion, interfacing between gray coded ADC outputs and binary based DSP systems. So the method or technique used to convert this code from one format to another is termed as code conversion. Code conversions are most commonly used in computers, digital electronics, microprocessors, etc. So there are different types of conversions in digital electronics. So the conversions includes binary to decimal, octal to decimal, hexadecimal to decimal, decimal to binary, octal to binary, hexadecimal to binary, decimal to octal, octal to hexadecimal, and binary to decimal representations of fractions. So this document discusses digital logic design and binary numbers. So what is conversing conversion code? So it's a process for converting a code of some predetermined bit structure such as like 5, 7 or 14 bits per character interval to another code with the same or a different number of bits per character interval. So in code conversion, alphabetical order is not significant. So coming to the code converters, so here we will go through the code converters. So before we start with the conversions like maybe binary to decimal or decimal to binary, first we will understand like what is this code converter. So code converters are the digital circuits or algorithms that are designed to translate the data representation from one format to the other format. So here we will go through the binary to other codes. Okay. So similarly, the other code conversions to binary. Binary to decimal conversion. So when I say binary system, so its base is 2. Okay. When I say octal number systems, its base is 8. Decimal number system base is 10. Hexadecimal number system is base 16. So binary number, we all know that binary number means it's a system that is defined as a number in binary systems. It is also called as base 2 numeral systems. So this represents the numeric values with two distinct symbols, basically 1 and 0. And what is decimal number system? The decimal number system is also known as base 10 numeral system. So this uses 10 digits from 0 to 9. In the decimal number system, the positions continuous to the left of the decimal point represents units, tens, hundreds, thousands, and so on. Thus, base of the decimal number system is 10. Now, what is binary to decimal conversion? Binary to decimal conversion is done to convert a number in a binary number system